Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 8. With me, Unzil Makfira Firdausi, and my friend is Ernita. We are going to explain about the article of chapter 18, with the title is Using Ethnomathematics Perspective to Widen the Vision of Mathematics Teacher Education Curriculum. So in the first section is about introduction or the background. In this article, there is a statement state that a narrow vision of mathematics that confines it to the school. Traditionally, mathematics has been taught from a narrow perspective, and this has resulted in the omission of significant contribution of most cultures and other groupings of people from academic mathematics curricula, and this exclusion can have the consequence of devaluing and disrespecting many students' cultural backgrounds. So, in this article, give an idea to transform a traditional mathematics curriculum. One way to address this issue is through teacher education, using it as a space to transform a traditional mathematics curriculum and thereby to challenge many prospective teachers' traditionally held perceptions of mathematics and its pedagogy. In the second section is about theory meaning. There are two definitions of the term ethnomathematics, with specific and with broad. With specific, the mathematics which is practiced among identifiable cultural groups such as national, tribal societies, labor groups, children of certain age brackets, and professional classes. In the Ambrosio, 1985, at page 45. The definition of the term ethnomathematics with broad is ethnomathematics is a research program of the way in which cultural groups understand, articulate, and use the concepts and practices which we describe as mathematical, whether or not the cultural group has a concept of mathematics. In Barton, 1996, in page 214. In this article, we'll discuss about the CRME in K 2000. So CRME is Culturally Responsive Mathematics Education. The key tenets of a CRME include the first, helping students connect academic mathematics to other forms of mathematics. The second is connecting school mathematics to the socio-cultural ethnical aspects of home culture. The third is enabling teachers with equitable pedagogical practices that cater to all learners. And the fourth is allowing both students and teachers to acknowledge and celebrate their own and each other's cultural background. The third section is about method. Researchers engage in a self-study with an emphasis on collaborative learning. This approach helped focus the lens on our own selves and enabled us to maintain focus on a more diverse variety of selves. Within the self-study, we have used narrative inquiry to organize, present, and analyze the qualitative data. That narratives are structured around a chronology of events, including course design and enactment, documentation of data, and our analysis and interpretation of data in relation to the chosen theoretical domain. The fourth section is about discussion. In this article, we'll discuss about the PST or phenomenon under study. So PST contribute data include their solution to mathematical tasks, course project artifacts, writing reflections, and summarize of their field experiences with middle school students. And there is an MTE. MTE contribute data include positionality statements and personal philosophies of teaching, course artifacts, summarize of their interaction with PSTS, collaborative reflective journals, and a shared understanding and analysis of PSC contribute data or UA. There are two objects of research in this article. So the first is University A, about content-focused coursework, and there are some activities. The first activity is teaching geometry using cultural artifacts. A beadloom, which is used by many ethnic groups, including many Native Americans, can be viewed as a pattern based on a Cartesian coordinate system and can be used to explore transformational geometry. Using virtual beadloom software, PSTS replicated beadloom patterns while at the same time making connection to their knowledge of symmetry and transformations. Sample of PSD responses. The first, technology-based construction of a beadloom. Look at the first picture. They choose the following design for the pattern. And the second picture, using linear iteration, horizontal and vertical reflections, they created a black X through the center. First, they choose the starting point as 0, 0. Then, they choose a line of 3 bits and iterated the line moving down and left for 10 rows. Then, they reflected the same image down, left, and right to complete the pattern. At the third step, they were able to somewhat easily iterate the red bits for the top and bottom, but they struggling to do it for the left and right. They can't get it to line up in the row they want it to go in. The fourth step is they decided it may be easier to work vertically at first and get all of those parts finished before trying to figure out the horizontal pieces. And the fifth step is working on the horizontal pieces. They have found that they can still iterate in the positive and negative y direction. Before they were trying to do it in the x direction and it was getting messed up. So in the next part will be explained by Ernita.
Okay, thank you. I will continue the explanation. This is for the second sample of the PSTS responses. Technology-based creation of a bedroom. In the left side, this is for the image of virtual bedroom. In order to replicate the image, they started by creating two large red triangles that were reflections of one another. For example, when they decided to make the vertices 0, 0, negative 20, 20, and negative 20, 20, they realized that the 0, 0 coordinate remain the same, but since the reflections occur over the y-axis, the x-coordinate will both now need to become positive, thus creating the other two vertices as 20, 20 and 20, negative 20, while the y-coordinate remain the same. Okay, next. Model of the bedroom. They repeated this process starting with the red triangle and a green triangle and reflected them over the y-axis as well. Once that portion of the bedroom was created, they had to perform reflections over the x-axis. They started with the orange or brown triangles and used 0, 0, negative 12, 20, and 12, 20. To perform a reflection, their new coordinates have to be 0, 0, negative 12, negative 20, and 12, negative 20. In this situation, the x-coordinates remain the same and the y-coordinates change. They repeated this process again to create the smaller yellow triangle. Okay, for activity 2, teaching geometry using a socio-cultural art form. When you are cross-stitching, you are basically plotting points on a quadrant plane. But instead of having the origin marked out for you and the x and y axis labeled and visible, you have to find it yourself and know where it falls within the pattern and on your fabric, as seen in the picture at the right side. When starting a new pattern, you always want to start in the middle and either start off stitching above the middle line, x-axis into quadrant 1 and 2, or work your way below the middle line, x-axis into quadrants 3 and 4. For the third part, then the figure below is Sandy is recreation. Sandy is one of the PSTS. Sandy is recreation of a five-pointed star on GeoGebra. She represents the art form to her peers and engaged in geometrical investigation on coordinate geometry, congruence, similarity, transformation, area, and perimeter. Second, for University B, early field experience in a non-Western country. Teaching fashion with ugali. Ugali is a local dish. Teaching fraction became a struggle as she attempted to demonstrate equivalent fraction, while the context she provided was a familiar one to her students. The vocabulary she used was problematic. It is terms such as renaming, numerator, denominator, and equivalent that she did not know the Kiswahili equivalents for were difficult for her to explain to her students. Hizabati ketika Kazi, Mathematics at Work, the PSTS asks their students to interview an adult to gather information about the mathematics they use at work. The PSTS's motivation for this assignment was to help their students see the value of mathematics outside of the classroom. The children were intrigued and amazed at how important mathematics is outside of the school setting. For the PSTS, they came to the realization that this was a very powerful lesson and we did not even know it. Okay, this for the third, return of the Kangas, transformation and Kangas. In the right side is the example of the translation in Kangas. Using Kangas also proved a useful tool to teach transformation. The BSTS took photographs of Kangas from a local market which highlighted the aspects of transformation they were teaching. By recognizing the significance of the Kangas in the Tanzanian culture, the PSTS were able to make valuable connections to the students while celebrating an important part of the culture. Okay, next. Okay, for the last, in University B is Mathematics in the Street. The PSTS also had opportunities to interact with various Tanzanians outside of the school setting and gain a broader perspective and appreciation of the importance of a non-Western view of mathematics. The PSTS were also surprised at how the tools calculate costs and change without a calculator or paper and pencil. One PST remarked, I'm in awe of how easily the thoughts do mathematics in their head. They are better at this than I am with a major in mathematics. During a world group discussion, the besties came to the conclusion that maybe we should think about math differently. It does not always have to be the way we think of math. Okay, next. For the conclusion, self-study conducted in the journal has a focus on how to explain and use ethnomathematical principles to question, understand, and re-evaluate the meaning of mathematics and its pedagogy. MTE explicitly models the main components of GRME to the PhD. It is very important to empower students by expanding, not narrowing down their mathematical knowledge. through inspiring their participation and creativity in contributing to the development of mathematical knowledge, and for teachers through the creation of culturally responsive mathematics teaching. Okay, this is for the last. Thank you for your attention. We are sorry from we are sorry if we made some mistakes. See you. Wassalamualaikum warahmatullahi wabarakatuh.